Managing users. As a DBA, you're going to deal a lot with end users. You might have them calling you up saying, hey, I forgot my password. Or they might need specific privileges to get something done, like create tables or drop constraints. So in this nugget, we'll talk about what the difference is between a user and a schema. Oftentimes, DBAs use these terms interchangeably, but there is a slight distinction. I'll show you how to create, alter, and drop users, and there's so many different options we can use. For example, you can define how you want this user to connect to the database, what kind of authentication, what table spaces they have privileges on, whether or not their account is initially locked, whether or not you want their password to be immediately changed when they log in the first time. There's all sorts of things you can do. Well, one of the things that you can define when you're creating a user is what profile it belongs to. Think of a profile as just a collection of rules governing password usage, system resource usage, and you can define a profile and attach it to a bunch of different users. So we'll also talk about the various privileges such as sysdba and sysopper and what types of system privileges are required to get things done, such as connecting to the database. Sometimes you'll have runaway sessions that were never killed off, and so they're just out there hogging resources. So I'll show you how to track those down and kill them off. I'll also show you how to find the various sessions and find out what kind of SQL somebody's using, because you might get some complaints from end users saying, hey, you know what, performance is just getting killed on this machine. What can I do? Well, you can drill down and find out who the culprit is and what their SQL is that they're executing. Well, as a DBA, you have some really powerful options as well. You can perform some auditing. In this nugget, we're just going to cover simple auditing, and in our security nugget, we'll talk more about fine-grained auditing. But auditing just entails finding out who's doing what on the database at a given time. And then I'll show you some various data dictionary views that you'll find very useful dealing with your end users. Now, a database user is simply someone who can log into the database. It might be a regular user, or it might be a user that has special privileges like sysdba privs. All of the objects that are owned by a particular user is called that user schema. So you might hear someone talk about Scott's schema. That's just the database objects that Scott owns. There's many different options for creating a user. Here's the basic syntax of creating one. All the keywords are in uppercase letters. So we say create user and then the username, identified by, and we have three choices. We can either say by password, externally, or globally. Now, by far the most common way of using authentication is by password. If you say externally, then you're relying on the operating system or some third-party tool to perform the authentication. This is considered not as secure as using password authentication. And your third option is to say globally. And you'll use that if you're using some kind of enterprise directory service, such as Oracle Internet Directory. But that is actually beyond the scope of this nugget. What we're going to focus on is password authentication. You have the option of defining the default table space for this particular user. So in this case, we're saying TS1. Now, if you don't provide that, then the default table space is going to be the database default table space. Well, if there isn't a default table space defined on the database level, then this user's objects are going to go in the system table space, which is considered a very, very bad thing. Same thing with our temporary table space. If we don't define it, then it defaults to the database level, and if that's not defined, it uses system. Once again, a bad thing. Even if you specify a default table space for a user, you still need to explicitly give them a quota on that table space for them to create any objects in it. So you can either say that a quota is unlimited, or you can give it a number, in this case 10 megabytes, or you can specify 0 to say, hey, I don't want to allow any more new objects on that table space. You can also set a profile for that user. A profile is just a collection of rules specifying how you want the password rules to behave and how you want the resources to be used. For example, you can specify how much CPU this user can utilize. If you don't explicitly state a profile, then it will use the default profile that's always there on the database system. And we'll talk more about profiles in just a moment. Setting a password to expire is considered to be a good security practice. All this does is it forces the user to enter a new password. And you can explicitly lock an account. By default, when you create an account, it's unlocked. Here's a really simple example of creating a user. Bare minimum syntax: create user, then the username identified by, and then the password. We can then dig into the data dictionary to see information about that user, such as what the default table space is and so on. So here we're grabbing the default table space and the temporary table space from DBA users where username equals. Make sure that this username is in all capital letters because all of our objects in our database are stored in uppercase. And the reason why this is the default table space and this is the temporary table space is that that is how it's set up on the database level. Let's create another user, John, identified by Doe. So that's his password. You can set up rules to make the password rules more complex. For example, you can say, hey, the password needs to contain an uppercase letter and at least 5 characters and maybe a punctuation mark. And we can do that all through profiles, which I'll show you in a moment. His default table space is the example table space, so whatever objects he creates will by default go there. Now, of course, he can override that and put an object in a different table space as long as there's a quota on that. His temporary table space for sorting is going to be temp. Quota unlimited on examples, so there's really no upper boundary on how much space he can take up on that table space. Really, the only restriction is how large that actual table space can get itself. He has privileges to create objects in the user's table space, but only up to 10 megabytes. Something to keep in mind. Let's say that John creates a table in the user's table space, but doesn't put any rows in there. And he gives someone else privileges to insert records into his table. If that user inserts a bunch of records and tries to exceed 10 megabytes, an error is going to be thrown. In other words, those quotas have to do with the objects that somebody owns. The first time he logs in, he's going to be prompted to change his password. And that account is initially going to be locked, which means he's going to have to ask the DBA to explicitly unlock the account before he can access it. Now, a profile is a set of rules that defines limitations on a user account. And so you can attach a profile and only one a profile to a user account. If you don't explicitly set a profile, then it will automatically inherit the default profile. You cannot delete the default profile from the database. So what exactly is inside of the profile? Well, here it is. Well, what exactly is in a profile? Well, we have kernel limitations and we have password limitations. For example, we can specify the number of concurrent sessions per user. We can say how much CPU can be used per session, and that number is going to be in 1/100ths of a second. We can also say how much CPU per call. A call is just a SQL statement. Logical reads per session determine how many blocks a session can read from the database. And then we have logical reads per call or per statement. You can limit the amount of idle time, time that you're doing nothing. Okay, so if someone's sitting there doing absolutely nothing for 20 minutes, you can say, hey, boot them off, disconnect them. You can also specify the connect time, as well as the private SGA. Now, this private SGA is actually used with a shared server option, which we'll discuss in a later nugget. The composite limit is a weighted average of CPU per session, logical reads per session, connect time, and private SGA. Now, the rest of these properties have to do with passwords. For example, failed login attempts is just that. How many failed login attempts do we have until our password is locked? Password lifetime tells us how long we can use a particular password in number of days. Password reuse time tells us the number of days between reusage of the same password. Password reuse max tells us the maximum number of times we could reuse a password. Now, the password verify function is pretty cool. What you're going to do is set this to a function, and that function is going to be just some explicit rules on how you want your password rules to behave. For example, you can say here that you want your password to be at least 8 characters, have a uppercase letter in there somewhere, you might specify that it has a punctuation like a dot or a dollar sign. You can get really detailed here. And I'll show you an example in just a moment. The password lock time is the number of days that a password will be locked until it is automatically unlocked. And password grace time is the number of days of grace time we have before our password expires automatically. You can look at the DBA Profiles view to dig up information on your profile. So here I'm looking at the default profile, and here are the different limitations. Most of these say unlimited, except for the failed login attempts, which defaults to 10, and the password verify function is not set to anything. We will change that in a moment. Now I'm creating another profile called Profile 1. Whatever I do not explicitly say in here will default to the default profile's values. So this profile says that I can have max number of 2 concurrent sessions per user, max time of 30 minutes for idle time, connect time is 480 minutes, which is 8 hours, 3 failed login attempts, password lifetime is 365 days. So basically the password can only be used for a year. Now you can do math with these different parameters here. So when I say password lock time of 1 divided by 1440 times 5, keep in mind there are 1440 minutes in a day. And so I'm just finding the number of minutes in a day times 5, so this means 5 minutes. And then I altered my user Jay Johnson to use Profile 1. After I created this user account a few minutes ago, I didn't give the create session privilege, which I need to do to allow Jay Johnson to log in. So grant create session to Jay Johnson. Okay, good. Now we're going to test out this user account. Let's test our limitations. Let's talk about the sessions per user. I'm going to log in as Jay Johnson in this window, do the same thing in another window, and then try it in a third. Okay, so I logged in there. And then in the third window, and then we get this error, exceeded simultaneously sessions per user limit. And this is the part where we as the regular user contact the DBA. Let's get rid of these sessions here. I'll exit out of here and exit out of my original window. Now I'll try to log in with the wrong password and test that limitation. So enter our password. I'll enter in something bogus. And then another something bogus. Try it one more time. And there we get our error message. And it bumps us out of SQL+. To utilize the password verify function, all you need to do is run a script that Oracle provides, and if you want to tweak it any, you can. So let's take a look at that script and see what's inside of it. You see here that I'm in my Oracle Home, RDBMS, admin, UTL pwd mg.sql. That's the built-in script. Okay, and really all it is some PL SQL code that defines a function called verify function. And you're going to run this as the sysdba. And you really don't have to be an expert in PL SQL to modify this. You just have to look at the comments and make any modifications as necessary. For example, this little chunk of code here checks to see if the password is the same as the username. If it is, then we've got a problem. It's not a valid password. This little block here checks that the minimum length of the password is at least 4. So if you wanted to modify this to say, well, it has to be at least 8, you would just change that 4 to an 8. You can also define a set of illegal passwords. It's just a comma-separated list here. And at the bottom of the script is how we can modify our default profile to have different values other than what we already have. So here we are setting the password lifetime to 60 days, the password grace time to 10 days, and so on. So if we run this script as is, it's going to change all these settings. So if you want to comment these out, you can. But it's this very last line that gets the work done. We say password verify function, and then the name of our function, which was defined up above. So now I'll go ahead and run that script. My function was created, my profile was altered, and I look at my data dictionary again at DBA profiles, where profile equals default, and here we go. See how these have changed? Now my password verify function is now this. Now to test it, we can modify someone's password and break one of those rules and see it in action. Alter user J. Johnson identified by cat. Password is not long enough. Or if we try J. Johnson identified by J. Johnson, since they're the same name, we're breaking a rule again. Let's revisit this profile parameter called composite limit. Remember that this is a weighted average of 4 different values. It's a weighted average of CPU per session, which is 1/100th of a second, logical reads per session, which is in blocks, connect time in minutes, and private SGA in bytes. Now remember, the private SGA is going to be used for the shared server option, which we'll discuss in a later nugget. So the weighted average of this resource cost can be modified, but it can only be modified on the database level. In other words, we cannot modify this on the profile level. So if you want to alter the resource cost, which we will do in a moment, you can, and then the composite limit is going to be compared to whatever the resource cost is, and if the user's composite limit has exceeded the threshold, then their session will terminate. So to see what the weighted average is, we say select star from resource underscore cost. Let's do that right now. And you'll see that all these are set to 0, which means our weighted average is nothing. This isn't being used at all. If we set one or more of those values, then only the values that contain a non-zero number will be considered in this weighted average. For example, if you want to change the connect time to be 5 seconds and CPU per session to be 8/100ths of a second, then just issue this alter resource cost command. And then you can do this select statement again just to verify that the changes have taken place. And I made my modification here. And you can now see that CPU per session and connect time are taken into consideration for the weighted average. If I were to perform an alter resource cost command again and then just set the logical reads per session, the CPU per session and the connect time values would stay the same. If you want to set one of these parameters back to 0, you have to explicitly do so. So now let's do a math word problem. Okay, now let's assume that a user is connected for 30 minutes and this user has used 300 seconds of CPU time. Okay, so we do the math. 30 minutes, so 30 times 5, which is part of our weighted average, plus 300 seconds. Remember, this value is measured in 1/100ths of a second, so we have to multiply this times 100, times our weight of 8. So that gives the user 2550 of composite time. So let's assume that this user has a profile using the composite limit, and let's say the composite limit is set to 2500. Well, this is exceeding the composite limit, and this user session is going to terminate. So let's modify the characteristics of profile 1. Okay, so we're querying DBA profiles, and remember we said all this stuff earlier. Let's set the composite limit to something besides the default. Remember, this default is going to be whatever value is set in the default profile. So we modified it by saying alter profile, the profile name, limit, and then we can modify any of these features. And we alter user Scott, profile, and then the profile name. User's been altered. After you successfully create a user, you do need to give that user explicit privileges to actually log in. So that's the create session privilege. If you want to allow this user to create tables and other objects, you need to grant that privilege as well. So create table just allows that user to create a table in his or her own schema. If you want to allow to create objects in other schemas, just say create any table or create any index if you're dealing with indexes and so on. Granting the unlimited table space lets this user create objects in any table space with an unlimited quota. Now this user will still need to have the explicit privileges to create those particular types of objects. Well, if you want to grant a bunch of privileges such as create table, create index, and so on, it might be easier and faster to assign roles. So there are a couple predefined roles called connect and resource. A role is just a database object that encapsulates a bunch of privileges, and then you can assign that role to a particular user. Now be really careful with this because in Oracle 9i, these roles contained a lot more privileges than in 10G. Let's look at the specific privileges associated with the connect role. We're querying DBA sysprivs where grantee equals connect, and in 10G it only contains create session. Like I said, in 9i it has a lot more privileges. And we'll do the same thing for our resource role. Okay, create trigger, sequence, type, and so on. So after you successfully create your user, you just give the grant command, grant connect, resource, unlimited table space, or whatever privileges you want, or whatever roles to, and the username. There might be times when you want to kill off sessions. Well, to do that, you need to query the $session data dictionary view, and that will give us information about the session ID, the serial number, the operating system username, the database username, and then a logon time. So once you drill down and find the session that you want to kill off, you just say alter system, kill session, and then in single quotes, you have the SID and the serial number. For example, here I ran that command and I found that Scott is logged on as of June 2nd. So if I want to kill him off, the SID is 144, the serial number is 184. Let's go ahead and kill this session. And it was killed. You can keep track of what users are doing on your database by performing auditing. Now in this nugget, I'm going to show you some real simple auditing, and then we'll get into more detail in a later nugget. So to make sure that your auditing ability is turned on, you need to make sure that your audit trail and audit file dest parameters are set. So your audit trail can be either DB for database, or it can be OS for operating system. DB means that the information will be available in the database. OS means that you'll look on the operating system for the files containing the trail. Both of these parameters have to use the scope equals SP file, and then once you do this, you'll have to bounce the database. We have a couple data dictionary views that tell us which things we're auditing. So this view here, DBA statement audit ops, tells us which specific statements we're auditing. For example, if we're performing a select on a certain table. And DBA priv audit ops gives us more general information about the system auditing, such as creating a session. If you want to turn on specific auditing, you do that with the audit command. So you say audit create session or audit create table. And if you need to turn it off, just say no audit, and that's one word. You can even turn on auditing only when something was unsuccessful. So this statement here is auditing create table only when that statement is by Scott and if it's unsuccessful. So after you turn on your auditing, you can then query the DBA audit session, which will show you just the log on and log off activity, and all of the other auditing actions will show up in the DBA audit trail. Take a look at my parameters. I have my audit trail set to DB, and my audit file dest is set to this path. Now this really will only mean something if I'm on Unix or Linux. If I'm on Windows, the audit file dest, if it's set to OS, will actually go to the event viewer, which can be viewed by going to your control panel and then administrative tools, and from there is the event viewer. So let's see which system privileges are audited. We're querying DBA priv audit ops, and we are auditing when Scott does a create session, audit system, or alter system. And here I just turned on auditing for create table by Scott, and I ran this select query again, and you'll see that create table is now showing. If I wanted to audit unsuccessful logons, for example, I could query DBA audit trail, and I would say where return code does not equal 0, because a return code of 0 means success. Anything non-zero means failure. So I can find out the username, terminal timestamp, and the log off time. Okay, see there's no log off time because obviously it was a failed attempt. But we do see that this failed attempt was on June 2nd. We could find the exact time that this happened by using the toChar function, just like I did here. So this happened at 8:45 at night. Let's review some of these data dictionary views. Remember that any of these views that begin with DBA can also be replaced with all or user, depending on what type of information you're trying to grab. So DBA users gives us general information about each user account. DBA profiles for the profiles DBA-TS quotas is for the table space quotas for each user. System privileges for a user. Remember, resource cost is the weighted average of those 4 parameters for the composite limit. Session privileges is something that actually every user can query, and this tells us what exact privileges that session has real time. $session gives us information about who's currently logged on. And then we have these data dictionary views dealing with auditing. Now there's a few more views dealing with auditing, and we'll get more into those in our security nugget. In this nugget, we covered our users and schemas, as well as creating, altering, and dropping users. We also went in depth on profiles and the resource cost and composite limit, as well as privileges for users to connect to the database. Hopefully you won't have to kill sessions too often, but if you need to, you now know how to do that. And then we've reviewed our data dictionary views. I hope this has been informative for you, and I'd like to thank you for viewing.